Hi everyone. So we have two more lessons. We have lesson today, which is going to cover section 1, 2, 3 right here. And then the next day is going to be a quiz review. We won't have a quiz just because of timing and everything, but obviously important that you work on the quiz review to make sure that you're reviewing and working through all the material that we've covered so far. Then next week we'll have one last lesson and then we'll start talking about like normal curves and all that stuff. And then after that, we'll do the test review, and the following week will be the test. So, and then just like that, we'll be on summer break, which I'm sure everybody's ready for. All right. I want to start this lesson by actually going over two homework questions that I typically get when I'm in the classroom. I want to go over number 4, and then I want to go over number 6. Okay, so in the last lesson we talked about how we can use our calculator to do simulations for us and to generate random numbers, which is kind of cool. In this problem it says the Addams family has 2 girls and 2 boys. They're curious how often a family of 4 has this exact outcome. Perform 15 simulations to determine the percentage of times this happens and list the simulations. So we have 3 features that we can use in our calculator. We have the random button, we have the random integer button, and then we have the random binomial button. Random binomial. This one is not necessary. We can't use it because this just gives us a random percentage. So it'll spit out like 23%, 18%, 69%, something like that. Random integer just generates random numbers that we want. So if we wanted to say pick 15 numbers from 1 to 100, it would do that. So that's not beneficial in this case. Whereas random binomial is, whenever we use the random binomial, we need somewhere in there a percentage of likelihood. So this is what we're going to use. We're going to say the random binomial. The first number asks us how many events we have, and we have 4. So we would put a 4 here. And the reason we have 4 is because there's 4 children. Then we would say that there's a 50% chance that we get a girl versus a boy, so 0.5. And then we want to run 15 simulations. So this is what you would put in your calculator, and you may want to do that with me. So we hit the math button, and then we go over to the probability button right here. And then we go down to this random binomial, and we're just going to enter those things in. So we're going to hit 4, comma, 0.5, comma, and 15. And this is how you'd enter it if you have an older calculator. If you have a new calculator, you would just put 4 and then 0.5 and then 15. It just prompts you what each of those are. Okay, when I hit enter, it's going to run 15 simulations for me. Remember, it says this family is curious how often this happens. In order for this to happen, what they're referring to, 2 girls, 2 boys, that means when it runs this simulation, I want to know when I get a 2. Okay, because a 2 would mean that I'm getting 2 girls, which then means I must also have 2 boys. Or it could mean I have 2 boys, which then also means I would have 2 girls. Okay, so I'm going to write these down. I can see that I have a 2, 2, 2, 1, 3, 3, 2, and then I'm going to scroll to the right. 3, 2, and I have 1, 3, 0, 1, 3, 0, 1, 2, 3, 3, and 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 15. Okay. Remember, we get to pick what we want these numbers to represent, but once we determine what we want it to represent, we have to be consistent. That means if I want this to represent boys, then all of these have to represent 2 boys, 2 boys, 2 boys, 1 boy, 3 boys, 3 boys, 2 boys, 1 boy, 3 boys. I could flip them and say I want this to represent girls, but then this would represent 2 girls. This would represent 1 girl, 3 girls, 0 girls. Okay? It doesn't matter which way we interpret it. In this case, it doesn't really matter because 2 boys and 2 girls means that I would be saying here's 2 girls, which means 2 boys. So I'm looking for all of the 2's. And in this case, there's 1, 2, 3, 4, 5 out of 15, which means that there's a 33.3% chance that a family of 4 would have exactly 2 girls, 2 boys. Okay. Number 6 was very similar to the last problem that we had covered. I just want to kind of hit some highlights in here. I set it up the exact same way, different money amounts, different percent chance. So if there's a 30% chance that a customer pops a balloon on any given throw, that means that you would be looking from 0 to 30%. Okay, anything between there means that that the person popped the balloon. You don't have to look at that. That's, I think, the easiest. You could also look from 70 to 100%, because that's a 30% window. You could go from 20 to 50%. Anything that creates a 30% window is what you want to do. But then you would have to look and say, okay, is it between 20 and 50, or is it between 70 and 100? So it doesn't matter. Like I said, I just think it's easier to go from 0 to 30. Okay. It says in here to simulate 20 games, so I'm just going to kind of do it like a couple. Just say, like, if I did 5, you obviously needed to do 20, but just to show you. So if I were to simulate, I would say I want to go to math probability, and then I want to hit that random button. Let's see, you're only throwing 2 darts. So I would hit enter and enter again. And I'm going to look between 0 and 30 just because, again, I think that's the easiest window to look between. Okay, so notice neither of those are between 0 and 30, so that means that they popped 0 balloons. So if I go 1, 2, both of these are not between 0 and 30, so again, popped 0 balloons. And the next 2, they're both not between 0 and 30, so we're striking out right now. So popped 0 balloons. And the next 2 popped 1 balloon. And then in the next 2 popped 0 balloons. So there's a lot of zeros. That means 0 balloons equates to $0. So each of these would be $0 one, and then 1 balloon would be $3. So you're really looking for that 2, so that way you can get 8. If we averaged all this, we would just add up all of these amounts. So we have 4 zeros and 1 3, divide by 5, and you would get 60 cents. So not really worth playing if it's going to cost you $5. Okay, but obviously run 20 simulations, but it should be pretty similar to that. Everybody's answers are going to be a little bit different. They do not have to match the answer key, but they shouldn't obviously be way off either. All right, let's move on to today's lesson. Today's lesson is actually a pretty interesting lesson. We're going to talk about some different methods of sampling. So not gathering data like we started the unit, but sampling. And then the back side of the notes, we're going to kind of hit on some review material and kind of this too. Okay, this is a lot to write down. If you could print this off, this would probably be the best one to print off, just because there's so much definition. Otherwise, you're just going to kind of have to do your own abbreviated version of this. Okay. Remember, everything can be found on that Google Doc sheet. Okay. Okay, so one of our types of sampling that we're going to cover is called a cluster sampling. It says with a cluster sample, naturally occurring groups of population members are chosen for this sample. So the big thing is here that it's natural how those groups are picked. This method involves dividing the population into groups by geography or other practical criteria. Some of the groups are randomly selected, while others are not. This method allows each member of the population to have a nearly equal chance, so that's important, a nearly equal chance of selection. That means it's a good way to pick a group since it's nearly equal and it's not biased. Cluster sampling is usually chosen to eliminate excessive travel or reduce the disruption that a study may cause. Okay. Let's see here. A systematic sample is a sample drawn by selecting people or objects from a list, chart, or grouping at a uniform interval. So that's the important thing if you're taking notes here. Systematic means uniform interval. That would be like if we chose every third person who walked into the classroom. Okay, this method involves using a natural ordering of population members, such as by arrival time, location, or placement on a list. Once the order is established, every nth member, meaning every third, every fifth, whatever it is, e.g. every fifth member is chosen. If the starting number is randomly selected, then each number of the population has a nearly equal chance, again, nearly equal is important, that means it's a good method of selection. Systematic sampling is usually chosen when relative position in a list may be related to key variables in a study or when it is useful to a researcher to space out data gathering. Okay, so the important part is that this number that is chosen is selected randomly. So if you wanted to put like numbers 1 through 10 in a hat and pick out a number and it said 3, then it would be every third person. But if you just go, well, I'm going to pick every seventh person, then it's not a good random sample, and this is not happening, this nearly equal chance. Okay, and that's what we want so that it doesn't create bias. All right. This next one usually gets confused with cluster up here, so we'll have to do some work to make sure we understand the difference between stratified and cluster. So these two are very similar to each other, but there's definitely differences that we're going to have to pay attention to. Okay. This one says, for a stratified sample, the population is divided into subgroups so that the people or objects within the subgroup share relevant characteristics. This method involves grouping members of the population by characteristics that may be related to parameters of interest. Once the groups are formed, members of each group are randomly selected so that the number of members in the sample with given characteristics is approximately proportional to the number of members in the population with the same characteristics. Stratified sampling has been used for many years to predict the results of the state and national elections. So I thought that was interesting. Okay, so here's what happens. Imagine that in a classroom, so let's say here's a classroom, it's kind of like a square. Let's say that every corner represented an interest. So this corner represented everybody who likes the color blue. This is the people who like the color red, and this is the people who like the color purple, and this is the people who like the color orange. Okay, everybody goes to the corner that of the color that they prefer the most. Okay, so let's say that there's 10 people over here, and there's 6 people over here, and there's 5 people over here, and there's 3 people over here. Okay, what you would do then is you would randomly select people out of those groups. So this is based off of their interests, and then you'd say, okay, because 10 represents, like 10 is the most amount of people, we're going to pick the most people out of there. So maybe we'll pick 3 people out of there who randomly win, and we'll pick 2 people out of here who randomly win, and 1 person out of here, and 1 person out of here. Okay, so what you're doing is you're grouping people based off of their likes, which is cluster, but then you're picking people within those groups. Okay, so you're not picking all 10, you're picking 3 out of the 10, you're picking 2 out of the 6. Okay, notice this is 30%. Notice this is 1/3, so 33%, 20%, 33%. So they're all about the same percentage. Okay, so stratified, if we wanted to make this a cluster, we would have said, okay, out of these 4 groups, we're going to randomly pick one. I picked purple. So all 5 of those people win. That would be a cluster. Stratified means that I'm going to group them into these groups, and then within those groups, I'm going to pick some from each group. Okay, that's the big difference. You may need to rewind and listen to that. All right. Next sample is a convenience sample, in which members are chosen in order to minimize time, effort, or expense. Convenience sampling involves gathering data quickly and easily. The advantage of convenience sampling is that in some cases, preliminary estimates of population parameters can be obtained quickly. So that's the idea of convenience. It's literally just whatever's convenient. It's not necessarily good, it's just quick and convenient. The main disadvantage of convenience sampling is that the samples are prone to serious biases. That means that this is not a good judge of numbers. So if you needed something quick, you would do a convenience sample, but that doesn't mean that it should be a good predictor of what's going to happen. So as a result, the estimates obtained are seldom accurate and the statistics are difficult to interpret, meaning it's just not a good estimate, but it's a quick, gauge of numbers. So that's the first one, convenience, that is just not a good sample. Okay, it does not create that equal amount that was said in all of these. Nearly equal chance of selection. Same thing with stratified. Okay. So convenience would be like, all right, I need to choose 5 people. I'm going to choose the first 5 people who walk through the door. There's nothing random about that. It's just convenient so that you don't have to wait for everybody to walk in. Okay. And then the last one is a simple random sample, which we've done simple. A simple random sample is a sample in which any combination of a given number of individuals in the population has an equal chance of being selected for the sample. Simple random samples do not contain sampling bias, uh, just like these three. These do not create sampling bias, whereas convenience does. For any sample size, all combinations of population members have an equal chance of being selected for the sample. By using this method, a researcher can eliminate intentional or unintentional, meaning biased or unbiased, advantages and disadvantages of any members of the population. Okay, so simple would be like everybody in the school gets a number, 1 through however many students we have, 2,500. And then I'm going to put all the numbers in a bag and I'm going to randomly select 5 numbers out of it. That's a simple random sample. We're not grouping anybody, we're just assigning everybody a number, picking a number. Okay. The next one, we're going to try to identify situations in which we get cluster, systematic, stratified, simple, or convenience. So a lot of times reading through the definitions, it seems like it makes sense, and then we get a scenario like these 5, and then it's like, ooh, which one is it? So this should help kind of clarify what each one would look like as an example. Okay. Sometimes reading through them and just picking out the easiest one is the best way to go, or if you recognize one and then don't get it, move on, skip it. Okay. So for instance, if we started with the first one and we said choosing a person in every 6th house. Okay, so every 6th house means that we pick one, then 6 houses later we pick another one, 6 houses later we pick another one, 6 houses later we pick another one. That would be your systematic. There's a system to it. So systematic. Okay, and in order to make this the best possible sample, you'd have to randomly select which house to start at. You can't just be like, all right, we're going to start in the first house and then go every 6, because your starting point needs to be random so that it maintains a good random sample. Okay, this would actually be a really good place to pause and see if you can fill out the next 4 just by process elimination if you need to. Okay, so try to pause, see if you can do this. All right, assuming you've attempted or at least maybe read through. If you haven't even read through yet, maybe pause and just read through. Let's see if we can figure out what the rest of them would be. The next one says choosing 4 people at random from every homeroom class. That seems like it would be systematic, but we've already used systematic. So let's actually skip that, move on, see if we can identify some of the other ones. The next one says choosing the first 5% of a baseball team who arrives at practice. The fact that we're talking about the first 5% means that this is a convenience method of sampling, because since we're just selecting the first 5%, it's easy. It's whoever gets there first, and we don't have to wait for everybody to get there. Okay. Okay. The next one says choosing 200 people at a Bulls game by selecting random tickets. So notice that we're selecting 200 people at a Bulls game by selecting random tickets. That's a simple random sample. It doesn't say anything about grouping. It just says you're selecting 200 people by selecting random tickets. That just means that everybody's ticket basically goes into a bucket, and you're just going to pull out the first 200. So that is the most simple way to pick, and it's actually the best random method. Okay. Next one says choosing about 200 people at a Bulls game by selecting multiple seat selections. These two are the two, like I said up above, that usually get confused because they seem kind of similar. We have cluster and we have stratified left. So one of them's got to be a cluster and one of them's got to be stratified. Okay. Remember the difference between them. Cluster means you group and you pick the whole group. Stratified means you group and you pick people from each group. Okay. So notice that this says choosing about 200 people at a Bulls game by selecting multiple seat selections. Okay. Notice it says multiple seat selections. This means that this would be a cluster because you're selecting the whole group. So you're picking multiple seat sections. That'd be like saying, I'm going to select section 123, and everybody in that group wins. Okay, and you keep doing that until you choose about 200 people. Okay, so if this is clustered, then this would have to be stratified. And it's okay if you have to use process of elimination to get here. But let's talk about stratified. Stratified, again, means that we group and we pick within those groups. So it's hard to see, but maybe we see it now. Notice it says 4 people at random from every homeroom. The homeroom is a grouping. It's a natural grouping. Okay, the school did it. You didn't do it based off of interest, but it's a natural grouping. So all students are grouped within their homeroom, and then out of each of those groups, 4 people are selected from each homeroom. Okay, that's a stratified. We're grouping, we pick within the group instead of picking the whole group. All right. If we flip over to the next side, we just have some random multiple choice and open-ended questions to kind of go through. And this is typically what the SAT would look like when they pick stats problems for problems to pop up. Okay, so this first one says, Mr. Hacker. Mr. Hacker is a science teacher who would like to estimate how many students in his school use the drinking fountain outside of his room. In order to get an estimate, he decides to count the number of students using the fountain starting at 8 a.m. Okay, so using the fountain starting at 8 a.m. Then every passing period, he continues his count. What type of sampling is this? Okay, so what this means is at 8 a.m., he's going to count how many people are outside drinking out of his drinking fountain. And then next passing period, he's going to continue that count. Next passing period, he's going to continue that count until he reaches the end of the day. So what type of sampling is this? Okay, there's 2 that we could say for this. One is that we could say that it's a convenience, just because it's convenient to him because it's what is closest to his room and it's on his schedule. So we could say convenience, and I would say that convenience is an okay answer. However, systematic is the better answer, I would say. So systematic is best, but both are justifiable in picking. Systematic would be the best because it's happening on a time frame. So while it is convenient to him, it's happening at specific intervals. So if you think about like our passing periods happen every 50 minutes, and then again 50 minutes later, 50 minutes later, 50 minutes later. So that's why it would be systematic. Okay, it is convenient because it's what's closest to him and it's what's on his schedule, but it's also on everybody's schedule since the bell rings for everybody. Okay. All right, number 7 says, which type of the following sample would be the most representative of all the students for a study that measures the average attendance for a school? Okay, most representative means that there is no bias. Okay, most representative means that it would be picking a good representation of the school, so a good picture of the school. Okay, so if we read through these, it says students are handpicked by teachers. Well, that's not a good representation because then students might be picking their favorite students, their least favorite students, the most athletic students, the students who sit closest to the front of the room. Who knows? But you can't just pick. It has to be random. So there's nothing random about this. B says students in band. That's obviously not representative because now you're representing only the people in band and nobody who's not in band. The next one says students with last name G through K. That would be a good representation if the letters G through K were randomly selected. Like groupings were, like A through C and then D through F, and then we're all thrown into a bucket and we randomly select those. So we're going to come back to that one. And then D says students who are sophomores, which obviously is not a good pick because you're talking about one grouping out of 4. You're excluding the freshmen, the juniors, and the seniors, which means out of these choices, this is your best group. Well, that is your best, most representative. So students with last names G through K, because that could represent people who are in band or not. That could represent sophomores, but also freshmen, juniors, and seniors. Okay, so that would be your best answer. In these types of questions where these are multiple choice questions, you really want to make sure that you read each and every answer, because while one answer may sound good, you might read another one that sounds better. Or in this case, you might read ones that sound like all of them maybe don't fit, but there's got to be one that's better than the rest. So really make sure you read through all of the answers. Okay. I need you to fix this right here. So right where it said, and it might be fixed in yours already, I don't know, but right here, just make that they make. Okay. So this says a boss of a law firm is trying to determine how much his associates make on average. He is going to pick 5 random people to record how much they make. What kind of study is this? Okay, we haven't talked about types of studies all the way since the first lesson. This is not a randomized trial, mostly because we haven't talked about what a randomized trial is. But then notice what the 3 remaining answers are. We have a sample survey, an experiment, and an observational study. And these are the 3 that we talked about in that first lesson. So it's been a while, so this is a good review. So he's going to pick 5 random people to record how much they make. This is not a sample survey, because a sample survey would cover everybody. And a sample survey would be like you throw something out, and then it comes back. But again, it would have to be everybody. And he's randomly picking 5 people. This is not an experiment, because there is no control group and non-control group. There is no incentive. So this would be an observational study. Observational study because he's not interacting. He's just sending out, getting answers back. He's not interacting or swaying them one way or another. So that would be an observational study. Okay. The next one says, what is sampling bias? So it's been a little while since we've talked about bias. So sampling a bias, just so we understand, is when it's leaning towards something. So it's when you read something and it seems like it's kind of pushing you in one direction and making you think a specific way. Okay. So let's read through all of the examples. So which one is a sampling bias, meaning that it's leaning towards something, pushing towards thinking some way? A says some members of the population have a better chance of selection than others. All members of the population have an equal chance of selection. That's not true. If there's bias going on, everybody does not have an equal chance of selection. The sample size is too small to be unbiased. That's not true. There's no such thing. You can't have too small of a group, which makes it unbiased. The sample statistics are less than or greater than the population parameters. That doesn't have anything to do with sampling bias, which means then it's got to be answer A. So what is sampling bias? The definition of sampling bias is that some members of the population have a better chance of selection than others. So remember, we talked about sampling today. Sampling bias just means that you would have a better chance of selection. So instead of being like, all right, there's 200 tickets in a bucket, somebody's going to pull 5, everybody's got the same chance. It might be like, well, this, I don't even know, like this person really likes the color green. So anybody whose ticket that's in there is green has probably got a better chance. That would be a sampling bias. Okay. Number 10 says, what is a stratified sample? So stratified, if you go back to the beginning, the front side, stratified again means that we group and then we pick within that group. So we want to pick which one of these answers best defines that. Okay. A says all members of the population have an equal chance of selection. This is the definition of a simple random sample. Okay, some of them, if you read back to on the front, have a nearly equal chance. A simple random sample has an equal chance. Again, that's you put 200 tickets in a bag and you pick one out of it. Everybody's got the exact same probability of getting picked. Okay. B says a population is divided into groups, and members of the same are randomly selected from each group. So members of the same are randomly selected. So notice we're grouping, we're picking within that group. That is a stratified sample. Okay, if we read through the other ones, let's identify what those are. C says a population is divided into groups and only some of the groups are chosen. Notice the groups are chosen. This is the definition of a cluster. So we group and we pick the whole group. Okay. The last one says each member of the population is assigned to a number and every nth number is chosen from the sample. This is systematic. So if we randomly pick that the 7th person is picked, then that is your system. Okay. All right. So the only one on here is not convenience, or is convenience. All right. Next one. Which of the following would not result in biased survey results? So we got to pay attention to what this is saying. Which one would not result in biased? So that means it's asking for unbiased. And the SAT loves to do this where they ask you these not questions. So we got to read through and determine which ones are unbiased, meaning neutral. Okay, sometimes it helps to kind of just read through and determine what they look like too. So if we ignore the word not and just think, okay, which ones are biased? It says conducting a survey of spending habits at a store on Black Friday. This is biased because if you're trying to conduct a survey of spending habits, you can't do it on Black Friday, which is like one of the biggest shopping days of the year. Your answers are biased. They're going to totally not be accurate. Okay. The next one says asking students to complete course evaluations of professors after they have seen their end of course grades. This is also biased because if they've already seen their end of course grades, depending on if they got a good grade, they're going to give the professor a good review. And if they get a bad grade, they might give the professor a bad review. So that's a biased answer. If they didn't know their course grades yet and then had to do the course evaluations, that would be unbiased. Okay. Distributing a survey about music preferences during second period. This would be unbiased because it's just you picked second period and everybody gets that survey during that period. You're not picking any one group over another. Everybody's got a second period class. Everybody gets it then. Okay. D says asking season ticket holders for feedback regarding increasing prices at the stadium. This would be biased as well. Okay, because it's asking season ticket holders for feedback regarding increasing tickets at the stadium. The season ticket holders are the ones who are buying tickets every single year. So asking them about increasing prices, you're not going to get a good answer because I would imagine everybody would not like that. Whereas if you asked a random group of people who aren't invested in it, they might be like, all right, it seems fair. Everything else in the economy is going up. Okay, so if you look based off of how we answer this, then we can look and better understand this not biased because we'll look at this and go, well, I can't, there's only one answer, this is the one that is unlike all the others. So my answer has got to be C. Okay, number 12 says, when is a sample survey more appropriate than a survey? So just getting at this idea of sample survey versus a regular survey, this would be the answer. So when the group is too large to practically survey everybody. Okay, so that happens even at like our school. It doesn't make sense to survey everybody. We might send it out to everybody knowing that we might only get 30% of responses. That would be a sample survey, even though you're sending it out to everybody. Okay, if you're talking about surveying like the entire nation, that doesn't make sense. You can't do that. You might randomly pick, I don't even know, 10% of the population. Okay. All right, so survey means that you get everybody. Sample survey means that you randomly pick a group within that everybody. All right, so hopefully those multiple choice kind of did some good review, and hopefully now we have a good idea of what sampling looks like. Your homework is out of the book, 1, 2, 3. I know you don't obviously have the book, so you're going to have to either print it out or work on a separate sheet of paper. It's probably pretty easy to work on a separate sheet of paper. You're just going to go through, and 1 through 4, you're going to talk about, is it a simple random sample? Is it a cluster? Is it systematic, stratified, or convenience? So you're just identifying which of the five it represents. So I would imagine since there's 5, one of them is left out. I don't think they double up on answers. So that's the first 4. I would just go back to the front side of the notes where we talked about all the definitions and the last couple questions where we actually talked about what they look like. Okay. In this one, you're talking about what a simple random sample, systematic sample, or cluster sample would look like if you had this information. And then in this one, random samples, so same thing, but just different information, and then that's it. So the back side of the notes was really to help you guys do a little bit of review, but this whole thing obviously focuses on those 5 types of sampling. Okay, I do have the answer key posted online. Again, everything can be found in that Google Doc. All right, thank you.